Hello everyone, I hope you're doing well. In today's video, we are going to solve the world's hardest easy geometry problem. Okay, before I start showing you the solution, you can try the problem yourself. You just have to find the value of x. You are given a triangle where um, the angles are given. This is 10, this is 10, this is 70, this is 60, this is 20. And you have to find this angle x. Okay. So before starting this video, I want to talk about something. Why am I calling it the world's hardest problem? Because the problem is kind of tedious. It's a, you need very much patience to actually solve this problem. Otherwise, you will just get carried away, swept away by emotions. Okay. Acha. And why am I calling it easy? Because this problem requires elementary geometry. We'll need triangle congruence. Uh, just recap. Congruence means that if you have three sides equal for two triangles, we'll say they are congruent. Basically, we are saying they are the same triangle, same triangle, same triangle, just maybe in different uh, কি বলে, different orientation. Like this is getting a very, like uh, I can draw this same triangle like this. Okay, but this doesn't change anything, na. This triangle is just this triangle. We have the three sides equal, three sides equal. Okay. Acha, there are other ways to prove congruence. There is the side angle side, which means that let's say you have two sides and one angle, two sides and one angle of two triangles same. If they are same, then those two triangle are also congruent. Okay. Uh, we say that if two angles and one side they are the same for two triangles, then that triangle is those two triangle, that pair is also a pair of congruent triangles. So angle, side, angle, a for angle, s for side. And if there are like if you have a right angle triangle, in that case, if you have like uh, two of the two of the any two of the sides equal, then they are congruent. Because just see, mane, we know from Pythagoras that c square is equal to a square plus b square. C is the hypotenuse, a and b are the like uh, right angle triangle adjacent sides. So if you have actually two sides, then you actually have the third side as well. So basically, right, for right angle triangle, two sides are enough. One side can be hypotenuse, can be any two. Anyways, after congruence, we need similarity. We just need small part of similarity, triangles similarity. When two triangles are similar, let's say triangle ABC is similar to triangle DEF, we say we use this sign. What do you mean by similar? Similar means that the angles will be same, angles will be same, angles will be same. Like this angle equals to this angle equals to this angle, this angles, this angle equals to this angle. Okay, we just took it a bit differently, but three angles are equal, so the triangles are similar, and we use this symbol to say similar. So triangle ABC is similar to triangle DEF. Okay, so in that case, we say that, let's say this is A, this is uh, this is, let's say this is B. Okay, this is A, this is B, this is C. We said the side opposite to A is A, so side opposite to B is B, small b. Side opposite to C is small c, and the same is for here. Let's say this is our C dash, C dash. This is our A dash. This is our B dash, and the sides are like this: a dash, b dash, c dash. So they are proportionate. A by a dash is equal to b by b dash is equal to c by c dash. That is what we mean by similarity. Okay. Our incongruence, the both of the triangles are exact same. Like they are like the same triangle, just maybe sometimes in a different notation, different orientation and all, but they are the same triangle, same area, same everything. The corresponding things are same. Are here corresponding things are similar, proportionate. Okay, like the angle opposite to, sorry, the side opposite to the angle, the side opposite to the angle, that ratio is same. Okay, then we might need to like the fundamental uh, things of geometry, like if we have two parallel lines, then the corresponding angles are equal, the alternate angles are equal, alternate angles are equal, the opposite angles are equal. Okay, the opposite angles are equal, sorry. Acha. The opposite angle, that means maybe this one and this one, this one and this one, opposite, direct opposite of the other, they are equal. Okay, like proving this, like if we just assume one of them, proving the other two is very simple and straightforward, but we are not going to prove any of this. So another thing, for this problem we need to like remember that the sides, the opposite angles are equal, equal sides have equal opposite angles, and vice versa, like equal angles mean equal sides. What I mean is that if two triangles have like this, this one, acha no. What I mean is that if we have a triangle and two angles are equal, then the opposite sides are equal. If we have a triangle where two sides are equal, then the opposite angles are equal. Okay, I guess I made myself quite clear. Oh, sorry, ulta. We are going to like maintain a convention like A, the opposite side would be A. For B, the opposite side would be B. So if A is equal to B, then A is equal to B. That is what I am saying. The angle A is equal to angle B. Okay. So now we can try solving this problem. Sorry for this recap. What we are going to use are parallel lines. Parallel lines. We say A parallel B by this symbol. Let's say AB parallel to DE, okay, or DF. We can say this by this one. We are using parallel lines, we are using similarity and congruence. Similarity and congruence. And we are using the isosceles triangles theorem. Isosceles triangles theorem. Triangles theorem. Which means that if we have like the A and B are equal, let's say both of them are Y, and we are, let's say we have to find X. So what will be X? The summation of all the interior angles is 180 degrees. Okay. So X plus 2y is equal to 180 degrees. That means X is equal to 180 minus 2y. And y is equal to 180 minus x by 2. Okay. We are going to use overall these fundamental things of like elementary geometry. And now we are going to attempt, take the brave attempt of solving this horrendous problem. Okay. So first things first, we will first find out the angles that we can find out. Find all the angles that can be found. Okay. So this will be 20. This will be 20 degrees. Why? This is sorry, this is 80, this is 80. So total is 180. So 180 minus 80 minus 80 is equal to 20. So C is 20. Okay. C is 20. I'll keep every rough here. Every rough here. Okay. Let's write it in a proper way. Like C, just get the part. C is equal to 180 minus 180, 80. 80 plus 80 is equal to 20. Okay. Then we can find this angle. What will it be? Uh, we can find this angle in a different way, to be honest. Let's say, let's include this part also. Exterior angle, exterior angle equals to the sum of other interior angles. Other interior. What I mean is that this this will be just the summation of this plus this. Okay, like this will be 30 degrees. Why? So we know all these theorems, right? I'm not going to prove those, but we can just see it in any ways. Like this is 70, this is 80, 150. This is in the triangle, so 180 minus 150, 70 plus 80. So this equals to 30 degrees. So that let's say, let's call it like BD and then call it E. Okay. So we are saying angle E in AEB, angle E in AEB is equal to 30 degrees. So this is 30. And what I was trying to say that this is same as like 10 plus 20. 10 plus 20. The interior angles that are not here. I mean the other two interior angles in the triangle ACE. Okay. We can call it like that way. I'm just erasing these parts because like otherwise it will get too tedious. Okay, what is the value of angle D here? Same 80 and this is 60 in this triangle ADB. This is basically what? 180 minus 180 minus 80 plus 60, which will equal to 40. And we could have found 40 in another way. If we see carefully that triangle BCD, in triangle BCD, D is the exterior D, the exterior angle D. That is the summation of the other two interior angles C and B. Okay, that also gives us 40. So can we find any other angle from here? Can we find it? We may try, but I don't see any ways to find any other triangle. Okay, this is 40. Okay, if this is 40, this is 140 because one straight line is 180 degrees, right? Okay, let's just see what else can we find from here. This is 20 degrees. No, we can't find this angle. We can't find this angle. Acha, what other angles can we find? This is 70, this is 60. 60, 70, 130, and this is then 50. This is 50, that means this is 50. Okay, but that doesn't take us anywhere. That is not taking us anywhere. Okay, let's try something else now, Taylor. Let's go. Let's try something else. Try doing something else. And this is the move that we need to understand that it will come to you if you are like practicing geometry a lot. It will not come to you like uh, what should I say, like this. It doesn't come to like to your head in a ziffy, in a, I don't know what should be the word we will need to use here. Anyways, I am going to do, this is the step 2. I am going to draw AB parallel DF. Okay. I am drawing a parallel line to AB, calling it DF. Okay. This is going to be very fun. Very, very, very fun. Let's keep it in a different color so that we realize it later. Okay. By drawing a parallel line, now we have two similar triangles CDF, similar to triangle ACB, or maybe I could have said, as I said CDF, I should say CAB. That looks better. CAB. Acha, why are they parallel? A triangle ACB. Acha, ACB will say so. DCF. Okay. So why are they similar? Because this, as DF and AB are parallel, that means this angle is equal to this angle, because they are the corresponding angle, where CA is the like intersecting line. Okay, we have DF and AB, and this is the intersecting line, CA. Okay, AB, DF. So this and this triangle, this and this angle, they are 80 degrees. This is 80 degrees, 10 plus 70. So 80 degrees, this is also 80 degrees. Oh my god. Both of them are 80s. So what can we say? For triangle ACB, we find out that AC is equal to BC. This is a isosceles triangle because two angles are same, 80 and 80. Okay. Two angles are 80 and 80. So we can say AC is equal to BC or ACB. They are similar triangle, not because they are similar. I am writing this because angle A and angle B are same. Similarly, we can find out that CD is equal to CF because the same issue, right? Angle D and angle F are equal. Just remember one thing. When I am saying D, I mean this D. Okay. Not like the previous one. When I am saying F, I am saying this F. Okay. I'm not referring to any other part. This part is independent of the previously seen parts. Okay. So, what else can we do? What else can we do? Okay, let's see what else can we do. We are going to join these two parts, A and F. A and F. And just see, here we have a point of intersection here. We will name this G and we will add the C and G. We will add the C and G. Maybe we could do that later. I just did it earlier. Sorry. This is a very tedious problem, to be honest. A lot of people will be like, uh, will not be able to like be with me till the end. A lot of people have already probably stopped watching this video. So we'll have to stay patient if we really want to solve this problem or really want to see where this problem is going. Okay. Uh yeah. Uh Today is the New Year's Eve almost. I wish you guys a very happy New Year. This is just my way of saying Happy New Year to people, like doing some math and all. People are having, people are using the like fireworks. They're doing the fireworks. Anyways, let's get back to our thing. We have find out CD is equal to CF and CA is equal to CB. So that means AD is equal to BF. Okay, because AC equals to uh, BC, and AC means AD plus DC, and BC means BF plus FC. And we saw it already that DC and CF are equal. DC means CD, the same thing. DC, CF, they are equal. So DC and FC are equal, so they got cancelled. We can say AD is equal to BF. So for now, we have like concluded things like AC is equal to BC, then CD is equal to CF, then AD is equal to BF. All of it will sink in some way or other. We have to keep patience here. Okay. So what can be done here? What can be done? What can we do? This angle here was 70. Okay. We find this angle here? Let's see if we can do that or not. Um, mhm. We'll need to do a lot of things here. One thing is for sure, like DF is like getting bisected by CG. Why? Because both of these angles are equal. This and this is equal. So that means C to this point is like midpoint of all of it. And we didn't even like connect the whole thing, thinking it a midpoint, but it actually, due to the isosceles triangle, it became the midpoint. Okay. But that is not going to take me anywhere for now. Let's see if it is going to take me. Okay, we found out these things like this is 10 and this is 10. This is also 10. Okay. So is it going to help me in any way? Let's see. It may help us. It can help us. Okay. CF for a triangle ACF. Let's see. We'll need to use a lot of congruences here. What can be those congruences? We have to think it through. Okay, we have already find out the angles here. Okay, this was what? This was 80, right? This is 40. So what about this angle here? The total is 180, so this is 60 degrees. Same for this one, this is 80. If we calculate this angle here, uh, oh, we don't know this angle here. So how do we calculate that? This is 80. This is same for this. This is common. And this is 80. This is 80. Oh, yay. For triangle ADB is congruent. This is the sign of congruence. Equal and then a wave above that. So triangle ADB is similar to triangle AFB. Sorry, is similar to not, is congruent to. Which means they are same. Why? Why are they same? AB is common side. And both angle A and angle B are equal, 80 and 80. For ADB, we have angle A hierarchy. We should we just draw it somewhere else? Okay, let's draw it somewhere else. Like this is getting too tedious, right? So if we for every congruence, let's draw it again and again. It will be a little tedious to draw it again and again, but it will do us something good. Okay, it will do us something really good. This is 20, this is 60. We must remember all that. Okay, so we don't need CG here, so we don't need DF here. But let's keep them that way. We are talking about two triangles, ADB and triangles AB. Triangle AB, ADB, AB. In both of them, AB is common. So AB will be equal to AB, right? So AB is common. And angle A is equal to this angle A, or we can say, let's write it properly. DAB, angle DAB is equal to ABA. Angle ABA. Okay. Then we have another. We just a little while ago we found out that AD is equal to BF. Okay. So this is the side angle side theorem of congruence. So because of all this, we can say these two are congruent. As these two are congruent, that means the opposite angles will be equal for these two, which means the opposite angle of AB in ADB, the ADB angle 40, that will be equal to the opposite angle of AAB triangle for AB, that is the AB angle. So AB is 40, this is 80, this is 80. So this means this is 60 as well. And if two angles are 60, this angle is also 60. And here comes the third part. If a triangle has all sides equal, then their angles are equal, and equal angles are each 60 degrees. So if three angles are 60 degrees or two angles are 60 degrees, I mean, as the sum is 180, if we know two angles, then we also know the third angle. Anyways, so these sides are equal. So which means we have a uh, equilateral triangle here. Okay. So these are all 60 and this is opposite. So this is 60. We already had this 60. So we understand that this is 60. So this total was 70. This total was 70. So that means this angle that I didn't specify at first, this is 10. Okay. This is 10. Why? Because this was 70. This was 70. This angle here, this angle here was 70. While something, this being something. So we just found out that this is 60 degrees. In this recent encounter, we found out that this is 60 degrees. That means this is 10 degrees. Hope I am clear. Because we'll have to like prove a lot of other congruences here as well. So let me just write them down. What we found out from this is equal to triangle AFB is equal to angle ADB is equal to 40. And due to this 40 degrees, we have DFZ, triangle DFZ is equal to 60. And we already found out that ZDF was 60 degrees. So from that, we can say triangle ZDF is equilateral triangle. All sides equal. Equilateral triangle. All sides are equal. And we also found out due to this is the opposite of that. So this angle is also 60. And this was already specified as 60. So this is 60. For as those two are 60, this is 60 as well. Because the total of any triangle is 180, and if two are 60, then the third is obviously 60. So basically it means that AGB is also triangle AGB is also a equilateral triangle. So We have find out a lot of things here. let let's think if we can find out any other things here. From just seeing the figure, we can already say that two triangles are what do I mean? Two triangles are congruent. What are the ACG and BCG? ACG triangle ACG and triangle BCG are congruent. That can be said from here, because this and this is equal. This is the common. If we calculate this angle, this will be the same. Uh, or we can say this and this already was same. AC and BC. So we got a lot of congruent triangles, but maybe that won't be needed here. Let's just go to the next step. Next step. I don't know how much time this problem is taking me. It just feels like that this is going to take forever. But let's just recap what we found so far. We have found multiple multiple triangles being congruent to each other, multiple sides being equal to each other. Let's say AD was equal to BF, CD was CF, CA was CB, CA was CB, and we get AG, BG equals to AB. Okay. Then similar for DG, ZF, FD. And we got triangles like this was E. We got angles like EAF is equal to 10. EAF is equal to 10 degrees, which is same as, like, let's say, okay, this was our X that we have to find out. EAF was 10. Okay, EAF was 10. Will we need that information again? I don't know. Maybe there is a possibility that we might need that information as well. Okay, let's now look at some some. Okay, let's look at FC and FA. Okay, FC and FA. What about them? At first, let's see. This is 20 degrees, right? The triangle ACF. We are looking at the triangle ACF, and we see that angle ACF is 20 degrees. It was we found this out in the first step. So ACF is 20, and as EAF is 10, that means CAF is 20. CAF is 20, which means this is a isosceles triangle, an isosceles triangle, and the opposite sides are equal, which means AF, the opposite side of C, will be equal to CF, the opposite side of A angle, because this is 10, this is 10, 10 plus 10, 20. Okay. Oh my god, this is taking forever. Can we solve this problem little earlier? Okay, let's again just um, let's just erase some of the things that we do not need right now. Okay, this being this, this being this. Just remember what the values were. The values that we needed were, this was 20, this was 60, this was 20, but this was 10, and this was also 10, and this whole thing was 20. Okay, this whole thing, this part, just this angle part is 20. Okay, let's look at some other triangles here. What triangles are like We have already said that CG is the bisection of uh, DF. Okay. Or we could have said that ACB is bisected by CG. Why could we say so? Because this is what happens when you draw a perpendicular line. But did we draw any perpendicular line? We just connected CG, na? So how did CG become the uh, bisector of ACB? How is CG bisector of? Okay, let's put this debate in another slide. So my question is that how is CG bisects ACB angle? How? If we already proved it, you can just comment it down along the timestamps. So how is this bisecting that? How are we coming up with that idea? Because there can be like CG can be any line, na? CG can be any line. It can be a lean line. It may not be the symmetric line I was talking about, na? So again, let's see. This and this was equal. This and this was equal, and this was equal. For that reason, this and this angle will be equal. I had already said that these two look, what do I say? ICG, sorry, ACG, BCG. I already said it, but I didn't prove it. Probably I forgot to prove it. So why? Because AC equals to BC and AG equals to BG and CAG, CAG, angle CAG is equal to angle CBG, which is 20. As both of them are 20, this is 20, this was 20, and this was 20. That's why this is congruent. Because of all the three lines above, this is from the side angle side, this is congruent. Let's write the side angle side. So as this is congruent, then this angle and this angle will be equal because they are the opposite of the same sides, the opposite of the same sides, right? So they are equal. So now you can say that CG is bisecting ACB. Okay, it couldn't have been said earlier without proving this. So this is 10 and this is 10. But as I draw the diagram very neatly, it could be like seen from the diagram. But what if the diagram is not to scale? What if the diagram is like faulty? Anyways, we got our values that we needed. Okay. So now we are going to see some other triangles here. Some other triangles may be congruent to each other. We have already found out ACG. So now we are going to look at triangle CAE. Okay, CAE. This is the. So let's see what we can do. This is 10, this is 10. CAE. So this triangle CAE, this angle is equal to 10. Okay. In ACG, let's say it like this. How does Dora ask you? Do you see the 10 degrees angle in triangle ACG? Where do you see it? ACG. The triangle ACG. That's 10 degrees. Okay, here. We just proved it earlier. This is 10 and this is 10. These two tens are equal. So we got one angle. Okay. So ACG. ACG. it would have been better if I just could erase the unnecessary parts that may not be needed here. Okay, so okay, let's remember. I guess we remember all the things that we need. So, in triangle CAE, in triangle CAE, we see a angle of 20, right? This is 20 degrees. ACE, ACE is 20 degrees. Do we see a 20 degrees in triangle ACG? ACG, this triangle is 20 degrees. This angle is 20 degrees. The CAG angle, CAG. So we got two angles. We need the side between them. If that is equal, then these two triangles I am talking about, they are congruent. So are they congruent? Let's see. ACG, ACG, CAE, CAE. Oh my god. ACG and CAE both have the common side, CAC, and they are equal. AC is equal to CA, and both of them contains these two angles. Okay, in ACG we have this angle and this angle. In CAE, CAE we have this angle and this angle. Just they are like flipped. This 20 is here. Sorry, this 20 is here. This 10 is here. Anyways, let's not draw like that. It will just confuse people more. Okay, I guess we got our answer. This is 10. This whole thing is 20. This is 10. This whole thing is 20. I guess you got my point, right? How the thing is like working in a way. Let's just erase the things for now. So what I mean is that both of them are congruent triangles, and as they are congruent, this and this and this, as they are congruent, what does that mean? That all the sides are equal, all the angles are equal, corresponding angles. Okay, so in ACG we have like CE, right? Sorry, in CAE we have CE. C is opposite to 10 degrees angle. So this will be opposite to this 10 degrees of angle, right? This 10 degrees of angle. Okay, again, this is 10 degrees. This is opposite in CAE. In ACG, ACG, this is the 10 degrees angle and the opposite is AG. So C is equal to AG. Although the diagram is not to scale, right? So visibly we can't say AG is equal to C, but from our uh, calculation we have find out that AG is equal to C. What benefit do we get from there? We had gotten another thing like uh, in some slides before we had found that CF is equal to FA or AF. CF is equal to AF, and AF is basically AG plus GF, and CF is basically what? CE plus EF. So from that, okay, CF is equal to CE plus EF, and we have find out that CE is equal to C is equal to AG. So that means EF is equal to GF. EF is equal to GF. And what benefit do we get from that? GD, GF, FD, that was part of equilateral triangle. That means these three sides are equal. And now GF is equal to EF. GF is equal to EF. That means EF is equal to FD. That means EF is equal to FD. Okay. Because of that, those equilateral triangles. Why? Why this is happening? Because DGF is equilateral. F. Equilateral. Equilateral. Lateral. Ah, so much drama. This was X. This was 30. If we remember correctly. Now, EF is equal to FD, which means what? This was 80 degrees. Now, this is the, let's draw the DEF. 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 Okay, this is X. This is 30. So, this whole thing is X plus 30. Okay. This whole thing is X plus 30. This is 80 degrees and these two are equal. These, acha, let's just even not write this part. These two sides are equal, EF and FD. That means this is also X plus 30. So X plus 30 plus X plus 30 plus 80 is equal to 180, which means X is equal to 20. And that's our answer. This is indeed one of the hardest easy geometry problems. I may have talked a lot during this session, but this is the whole thing. Let's just go through a recap. We had to prove multiple things here. At first, we found out the angles that we could have found easily. Then we did some drawing. We drew a parallel line AB parallel DF, and then we found out that AD is equal to BF, and we then drew the C and G, CG, and I was saying things like that DF is getting bisected by CG, but that was not proved there. I was just saying out because I was thinking it will work out like that. It was never said that this is a perpendicular, so I couldn't have said it there yet, until I proved this is 10, this is 60, and a lot of other things. This and this triangle are congruent. When I managed to prove those two, after getting this as 10, this was 20, this was 20, and this was the common, sorry, where do I begin? This and this was, this and this was same. This was the common side, and after proving those two congruent, then we could say that this was the, obviously this was the midpoint of uh, CG was bisecting our ACB angle. After that, or after only that, we could say that ACG and BCG were congruent. Then we proved that we have two triangles that are equilateral, the AGB and DGF. Anyways, then we went here. What did we prove? We proved AF is equal to CF. This was indeed a very tedious problem. If both of us survived this far, then congrats. And if you could solve the problem on your own, then bravo. Do let me know how you did you like this video. Like, this is the most traumatizing, most tiring, most disgusting problem ever. It takes a lot of patience. I guess I was a bit like flabbergasted. No, I was a lot overwhelmed during this whole process. So my English wasn't good. Please forgive me for that. But I guess you If you are like a true math enthusiast, you may have liked this video. Anyways, I'll go nuts. I just solved it and it's enough. Uh, I'll say after seeing the solution, if you ever feel that you have time in your hands and you want to give hard things a go, then try solving this problem on your own. Okay, bye for now. And again, Happy New Year.